the next group of problems, we're actually told to divide things that contain i's. We're not actually going to do division. Instead, what we're going to do is make sure that we actually don't have any i's in our denominator in our final answers. Much like in a college algebra course when you're told to divide something like 1 divided by the square root of 3. We didn't actually divide, we did something else called rationalizing. And the idea behind rationalizing in a college algebra course was that you can't leave a final answer with a square root in the denominator. So what you learned to do was to multiply the bottom by the square root of 3. But to keep it balanced, you also had to multiply the top by a square root of 3, which ended up giving you the square root of 3 now on top. And on the bottom, the square root of 3 times the square root of 3 just gave us a regular 3. They didn't cancel out completely, but the roots fell away from the denominator because they were identical. And that was the goal, was our final answer here has no roots in our denominator. That's going to be the same idea when we look at something like negative 7 over 3i. The answer is fine, but we can't leave it like this because it has an I in the denominator. So the question becomes, how do you get rid of the I in the denominator? It's okay if it's on top in the numerator, but not in the denominator. So what we can do is actually multiply the bottom just by an I, but if we do that to the bottom, we also have to do that to the top. And so what happens is we end up with a negative 7 now I on top. Then on the denominator, we also need to multiply the denominators out. Well, we ended up with a 3i times an I. That doesn't mean that everything is going to vanish. What it does give us, though, is a 3, and then the I times I gets us an I squared. The reason why that helps, though, is remember that our I squared can get turned into a negative 1. So we'll have our I squared turning into a negative 1, which means then we have a 3 times negative 1, which is negative 3. And we had our negative 7i on top. And so then we have a negative divided by a negative, which does turn into a positive, which gives us a positive 7/3 I, or you can write it as 7i over 3. It doesn't matter. They both mean the same thing, but notice that the I is on top, not on the bottom anymore, which was what the goal was. In problem B, let's take a look. We have 19 minus 9i over I. Same idea here. We have an I on the denominator, and we don't want one in our final answer in the denominator. So we're going to do the same trick. We're going to multiply the bottom by an I, but then that means we have to multiply everything on top by an I as well. And let's see what that does for us. That means that the denominator doesn't cancel out, but we do end up with an I times I, which is I squared on the denominator. But multiplying out the entire top by an I means that we actually end up with 19i minus 9i squared. Be careful. It is awfully tempting to want to cancel out those two I squareds, but you can't unless you can cancel out an I squared out of each and every piece on the top and the bottom. So we can't do that. However, we do have the I squared on the bottom that we can turn into a negative 1. We do have the 19i on top, minus 9, and I can turn that I squared on top into a negative 1. So let's see how that will help us. So now we've got the 19i on top, and be careful, now we have on top a negative 9 times a negative 1, which will give us a positive 9. And then this whole thing has a negative 1 on the bottom. The question is, what does it mean to divide everything through by a negative 1? It means that everything gets divided through by a negative 1. The 19i is going to get divided by a negative 1, and the positive 9. So what that means is my positive 19i is going to turn into a negative 19i. And my positive 9 is also going to turn into a negative 9. Now, if you were to type this answer into my math lab, you would get a nice, you're close but not quite, because remember, we want it in A plus BI form, which means the I needs to be at the end. So all I need to do is one extra step is I need to reorder this so that the negative 9 comes first, and then the negative 19i comes second. So I get negative 9 minus 19.